Hi learners! In today's video, you will learn what similar figures are and what conditions must be present for two polygons to be similar. You will also learn the different triangle similarity tests and how these are applied in verifying if two triangles are similar or not. Solving for an unknown angle and or side for two triangles that are similar is also demonstrated. Strategies in analyzing and solving word problems on the topic are showcased to let you experience how these are done so that you will be able to successfully answer geometry problems similar to these in the future. If your lesson is on similar figures, or if you have an assignment on this topic, or if you are preparing for a test in math, or a test in geometry in particular, or you are someone who is interested in learning math, then this video is for you. Let us start by describing what polygons are. Polygons are closed figures with at least three straight sides. Triangles and parallelograms are some examples of polygons. Similar polygons or figures are figures with the same shape but not necessarily of the same size. The paintings shown here are similar. How do we know that the two polygons are similar? Polygons are similar when their corresponding angles are congruent and the ratio of their corresponding sides are the same. Let us look at parallelogram NOPQ and parallelogram CDEF that are here. Look at their corresponding angles. The corresponding angles are congruent as shown by the same number of arcs. Thus, angle N is congruent to angle C, angle O is congruent to angle D, angle P is congruent to angle E, and angle Q is congruent to angle F. When the corresponding angles are congruent, that means that the corresponding angles have the same measures. Let us look at the corresponding sides this time and take the ratios. We have NO over CD is equal to 2 over 4 is equal to 1/2. OP over DE is equal to 1/2. PQ over EF is equal to 2 over 4 is equal to 1/2. And QN over FC is equal to 1/2. What are the ratios equal to, learners? Right, the ratios are the same. They're all equal to 1/2. Take note, it is not the measure of the corresponding sides that are the same, but the ratios. When the ratios of the corresponding sides are the same, then the measures of the corresponding sides are proportional. Since all corresponding angles are congruent and all corresponding sides have the same ratios, then parallelogram NOPQ is similar to parallelogram CDEF. Thus, polygons are similar when their corresponding angles are congruent and their corresponding sides are proportional. The common ratio is also called the scale factor. The symbol for similarity is this. For the parallelograms that we have here, we can write this similarity statement. NOPQ is similar to CDEF. Now, is triangle GHI similar to triangle QRS? We will investigate. By inspection, we see that each pair of corresponding angles is congruent, as shown by the number of arcs. For the sides, we have to check the ratios of the corresponding sides. Here they are. GH over QR equals 1/2. HI over RS equals 1.5 over 3.0 equals 1/2. And IG over SQ equals 2 over 4 equals 1/2. From here, we see that the ratios of the corresponding sides are the same. So both conditions for similarity are satisfied. That is, corresponding angles are congruent and the ratios of the corresponding sides are the same. So the triangles are similar. Thus, for these triangles, we can write this similarity statement. Triangle GHI is similar to triangle QRS. You have to remember this, learners. You can only write the similarity statement or say that the two figures are similar after you have done similarity test. If after testing you found that the corresponding angles are congruent and the ratios of the corresponding sides are the same, then similarity statements about the figures can be written. When writing the similarity statement, make sure that the corresponding angles are in the same order for both polygons. The order of the letters of the names must be able to tell you which angles are corresponding to which and which sides are corresponding to which. In the case of these two triangles where triangle GHI is similar to triangle QRS, angle G corresponds to angle Q, angle H corresponds to angle R, and angle I corresponds to angle S. In like manner, GH corresponds to QR, HI corresponds to RS, and IG corresponds to SQ. There is good news, learners. When testing for similarity in triangles, we do not have to test all three corresponding angles and all three corresponding sides to test for similarity. The following combinations is enough to conclude that two triangles are similar or not. First, AA. That is, two pairs of corresponding angles are congruent. This follows that the third angle pair is also congruent. Thus, in some cases, you will see AAA test. But again, you do not have to test all the three corresponding angles. Two pairs of corresponding angles, AA, that are congruent are enough. For when two corresponding angles are congruent, it follows that the third corresponding pair is also congruent. Second, SSS. That is, three pairs of corresponding sides have the same ratios. Let us look at the triangles that we have here, where the side measures are given. How do we know that triangle BCD and triangle FGH are similar? All we need to do is test for similarity by getting the ratios of the corresponding sides. If the ratios of the corresponding sides are the same, then the two triangles are similar. Let's go. Setting up the ratio gives us the following. BC over FG is equal to 1 over 3 equals 1/3. CD over GH is equal to 1.5 over 4.5 is equal to 1/3. DB over HF is equal to 2.0 over 6.0 is equal to 1/3. Here, we see that the ratios of the corresponding sides are all the same. So, the two triangles are similar. That is, triangle BCD is similar to triangle FGH by SSS. Third, SAS. That is, two pairs of corresponding sides have the same ratio and a pair of an included angle is congruent. The included angle is the angle between the two corresponding proportional sides as shown by the illustration here. To determine if the two triangles are similar by SAS, we check for the ratios of the two corresponding sides, and then we also check for the angle measures of the included angles. The figures show us that the included angles are congruent, for they have the same number of arcs. That is, angle O is congruent to angle R. We just need to test the two pairs of corresponding sides. We'll start by setting up the ratios of the corresponding sides, then get the ratios. So, PO over RS is 8 over 4 equals 2. OQ over RT equals 6 over 3 equals 2. We see that the ratios are the same, so the triangles are similar. That is, triangle POQ is similar to triangle SRT by SAS. Again, before any statement about similarity on triangles is made, we first have to test for any of the three combinations of angles and or sides for similarity. If the ratios are not the same or the angle measures are not equal, then the figures are not similar. It should pass the similarity test before any statement on similarity is made. Okay, so which polygons do you think are always similar? You are correct. Equilateral triangles are always similar. All the three angles in equilateral triangles have the same measures as shown here. So whether the triangles are large or small, as long as they are equilateral, the first condition for similarity, which is AA, is satisfied. Hence, they are always similar. On the other hand, two rectangles cannot be similar all the time. In some cases, they could be similar, but not all the time. Look at the figures that we have here. Here, the corresponding angles may be the same, but the corresponding sides do not have the same ratio. One corresponding pair of sides has a ratio of 1/2. The other corresponding pair has a ratio of 2/8 or 1/4. So the rectangles are not similar in this case. Now, two isosceles triangles cannot be similar all the time as well. Although isosceles triangles have two angles that are congruent, it does not guarantee that the corresponding angles of two isosceles triangles are always congruent. Let us look at the figure here. Triangle ABC and triangle EFG are both isosceles triangles, but the measure of angle A is not equal to the measure of angle E. Also, the measure of angle C is not equal to the measure of angle G. And obviously, the measure of angle B is not equal to the measure of angle F. So, the two triangles in this example are not similar. It failed the AA test or AAA test for similarity. But if the two isosceles triangles pass the similarity test, then they could be similar. Now that you have learned how to test if two triangles are similar, how will you solve for an unknown angle or side of a triangle if the triangles are given to be similar? We first solve for the unknown angle. The following must be considered when solving for the angle. First, identify which angle corresponds to which. Remember that the name of the triangles will help you here. Second, determine the measure of the corresponding angles. Remember that the measure of the corresponding angles are the same if the figures are similar. Third, use the angle sum theorem to find a missing angle if two are already given. Here's the problem. Sample problem 1. If triangle RST is similar to triangle XYZ, what is the measure of angle Y? As usual, we begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are we looking for, her learners? You are correct. We are to find the measure of angle Y. What are given? We are given that triangle RST is similar to triangle XYZ. To answer the question, we have to determine which angle corresponds to angle Y on the smaller triangle. If it is difficult to determine this on the drawing, look at the names of the triangles. The corresponding angles must be of the same order. So it is S, right? Since the triangles are similar, we have to get first the measure of angle S to get the measure of angle Y. Remember that the sum of the angles in a triangle is 180 degrees. What number, when added to 80 and 40, gives 180? Correct, 60. So the measure of angle S is 60 degrees. Since angle S and angle Y are corresponding angles, the measures of angle Y and angle S are the same. So the measure of angle Y is 60 degrees. That was easy, right? Now, let us consider solving for an unknown side. Sample problem 2, here is the problem. If triangle FGH is similar to triangle MNO, what is the measure of side NO? A figure is given. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What are we looking for, learners? You are correct. We're to find the measure of side NO. What are given? We're given that triangle FGH is similar to triangle MNO. The following are the things to be considered when solving for the unknown sides when two figures are similar. First, determine which sides correspond to which. The figure or the name of the figures will help you here. Second, set up ratios for two pairs of corresponding sides where one ratio contains the unknown side. Third, put the two ratios into an equation for the ratios of the corresponding sides are equal if figures are similar. Fourth, solve for the unknown. Here, side FG corresponds to side MN, so we set up the ratio. FG over MN is 5 over 2. Likewise, side GH corresponds to side NO. We again set up the ratio. So we have GH over NO is equal to 6.5 over X. Since the two triangles are similar, the ratios are the same or equal. So we have this 5.0 over 2.0 is 6.5 over X. Through cross multiplication, we have X times 5 equals 6.5 times 2. Dividing both sides of the equation by 5, we have X is equal to 2.6. There you are, learners. The measure of side NO is 2.6. That was again easy. I hope you acquired lots of learnings in today's video. Let us then summarize what we have learned in today's video. We have learned that polygons are closed figures with at least 3 straight sides. Triangles and parallelograms are some examples of polygons. Second, similar polygons or figures are figures with the same shape, but not necessarily of the same size. Third, polygons or figures are similar when their corresponding angles are congruent and the ratios of their corresponding sides are the same. This common ratio is also called the scale factor. Fourth, similarity statement on two figures can only be made after passing the similarity test, which are, first, that corresponding angles are congruent, and second, that the ratios of the corresponding sides are the same. Fifth, the similarity test for triangles are AA, that is, two pairs of corresponding angles are congruent. B, SSS, that is, 3 pairs of the corresponding sides have the same ratios. C, SAS, that is, 2 pairs of corresponding sides have the same ratios, and a pair of an included angle is congruent. Sixth, to solve for the unknown angle when two triangles are similar, follow these steps. A, identify which angle corresponds to which. Remember that the names of the triangles will help you here. B, determine the measure of the corresponding angles. Remember that the measures of the corresponding angles are the same if the figures are similar. C, use the angle sum theorem to find a missing angle if two are already known. 7, to solve for the unknown side when two triangles are similar, follow these steps. A. Determine which sides correspond to which. The figures or the names of the figures will help you here. B. Set up ratios for two pairs of corresponding sides where one ratio contains the unknown side. C. Put the two ratios into an equation for the ratios of the corresponding sides are equal if figures are similar. D. Solve for the unknown. Eighth, when solving a problem, you must read it and may read it several times when needed to know what you're looking for, to determine what are given, and to figure out how the given information help find what you're looking for. Ninth, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. Hope this video helps. That's it for now. If you have any questions, leave a comment below. And do not forget to like, subscribe, and share this video to your peers so others will learn too. Bye.